In this podcast, we'll be solving equations involving exponents. And we're going to look at two different types of equations, and they're differentiated because of where the variable is located in each equation. In the example 1, you can see that x is called the base. It happens to have an exponent on it. This is called a power equation. Example 2, the variable that we're trying to find is in the exponent. That's called an exponential equation. So we're going to compare and contrast the different steps involved in solving each of these equations, beginning with this first one. The first thing that I notice when I'm trying to solve this equation is I want to isolate the x. I want to get the x as by itself as quickly as I can. I'll do that first of all by adding 4 to both sides. So on the left hand side I'll have 19 x to the 2/5, and adding 4 to both sides would give me a 41. And then I'm going to divide both sides by 19. Because this exponent only applies to the x, it does not apply to the 19, I'm going to want to get that x by itself. So x to the 2/5 is 41/19, which doesn't divide very nicely, so I'll just leave it in that form. Now the next step is going to involve undoing this exponent, and there's a property of exponents that says when you raise both sides to an exponent, that something that has an exponent to an exponent, you multiply the exponents together. So I'm going to do that, and I'm going to choose to to raise both sides to the power of 5/2 on both sides. And the reason I'm choosing to do that is because when I do an exponent to an exponent, these exponents are going to get multiplied together, and 2/5 times 5/2 is 1. So we always raise both sides to the reciprocal power. That would leave us an x alone on the left-hand side, and then I'm going to pick up a calculator and I'm going to type in parentheses 41/19 to the, and then you'll need parentheses on the 5/2 as well, so be sure to type that correctly. That whole thing becomes an exponent, and when you do that, you get 6.84 when you round to hundredths. So in the power equation, the way to get rid of the exponent so that the base is by itself is to raise both sides to a reciprocal power. That's a type 1 problem. In our second type of problem, this is an exponential equation. Again, I want to get the x by itself, so I'm going to try to get as much away from it as I can, beginning with the 22. When you look at this first initial problem, the 2x exponent does not apply to the 22, so I'm going to want to get rid of the 22 first by division, much the same way in this example I got rid of the 19 by division. So 1.3 to the 2x power is the same as 14 divided by 22, which reduces to 7/11. The next thing I'm going to do is note where the exponent is. And we know that to undo an exponent, we have to write it in logarithmic form, since exponents and logarithms are inverses of each other. So in logarithmic form, this looks like log. The base is whatever has an exponent on it. That's the 1.3 here. Remember this reduced to 7/11, so I'm going to write it as 7/11 equals the exponent. And remember, the sole purpose of logarithms is to solve for an exponent, so we've just solved it for the exponent. Now, we know that there is a property of logarithms that says it's called the change of base property, and we can change this to any base that we like. I prefer to use a base 10 or a base e because I have buttons on my calculator that do that for me. So I'm going to change mine to base 10, and remember, when you write in base 10, you don't have to write the base at all. It's assumed to be a 10. So on my calculator, I'll be doing the log of 7/11 divided by the log of 1.3, and then of course be in parentheses. Be sure when you type this to close the parentheses, both the numerator and denominator, and that's what 2x is going to equal. And when you type that in, you're going to get some number, and then you're going to take that number and divide it by 2. So type this in, hit enter, divide it by 2, because we're solving it for 2x, and x will be approximately -0.86 when you round to hundredths. So to get rid of a power equation's exponent, you raise both sides to the reciprocal exponent, but in an exponential equation where you're trying to solve for the exponent, you use logarithms. That's the only time that you're going to use logarithms.